Hi everyone, thank you for coming to this session, which is titled of Protecting Brand Trust with Nanotechnology, Blockchain and DAML. My name is Pete Harris. I work for a company called Quantum Materials Corporation, and I'll be co-presenting with Danl from Digital Asset. So because Quantum Materials is a public company, I have to show you this, and this basically says that I'm not here to try and get you to invest in the company. What I can tell you about the company is it was founded in 2007. It's a nanotechnology company. It's based in St. Marcos, Texas, based on the Star Park, which is a facility owned by Texas State University. And St. Marcos is about 30 miles south of Austin. Today's presentation, we're going to cover a few things. We're going to talk a bit about the global problem of counterfeit goods, and counterfeit goods undermine brand trust. We're going to talk a bit about how to physically link physical goods to the digital world, like a blockchain. We'll introduce some things called quantum dots, which is what Quantum Materials produce. We'll talk about how they can be used to actually work against counterfeit goods. We'll talk a little bit about the tech stack for a platform we've built with Digital Asset and other companies. And then Dan will talk more about the DAML smart contract language and how that's being used in the world of blockchain. So I've got quite a lot to cover. I'm going to present a little bit, Dan's going to present a little bit, and I think after that we'll take some joint questions. So the world of counterfeit goods. At least $1.8 trillion criminal business involving everyone from mum and pop shops up to the mafia. It is, say, a massive business. It's growing. An awful lot of business is actually resulting from the rise in online e-commerce, like Amazon, eBay, etc. That's quite an old figure. It's really on the rise. In fact, yesterday there was a bipartisan bill introduced to the US House of Representatives. I think it's something called the Shop Safe Act. And the purpose of this act is to make platform companies like Amazon liable for selling counterfeit goods. So we'll see how that one goes. To anyone here who thinks counterfeit goods is really all about expensive, luxury, high margin items and those being counterfeited, then yes, they're certainly part of the counterfeit problem. But in actual fact, just about everything that you might buy is the target of counterfeiting. And counterfeiting impacts financial results of companies. It impacts, therefore, tax that they pay and the use of that tax in helping social programs. It certainly impacts quality of products. It could impact safety of products. All of that undermines brand reputation and brand trust. 2 or 3 quick horror stories about counterfeiting. I say it's much more than an expensive handbag being copied. Aquafresh toothpaste, an awful lot of that was counterfeited, found in a local market, contained toxic chemicals. Probably not best to use that. Airbags for your Honda. If you've recently had an airbag fitted in your Honda motor car, there's a good chance that might have been counterfeited and they don't work. So that's a bit of a shame. If you like Jameson's Irish whiskey and live in Zimbabwe, don't drink it because you'll die. So the list is frankly endless. The most traumatic story I heard was how there's a rampant business in counterfeiting garden tools. Would you believe it? And when I heard that, I was so traumatized I couldn't rake my leaves for at least a month. But so literally everything that you think of could be counterfeited. It's not just high-priced items. And so looking at how approaches to really fighting against counterfeit goods. We've heard, I think, how blockchain's being used very successfully in supply chain applications, in track and trace. Systems like the IBM Food Trust is a great example of something working very well. And typically for a track and trace kind of application, really just tagging a product or tagging a package is really what you want to do. And so using stickers with UPC codes, QR codes, maybe using RFID tags, that approach works pretty well for track and trace. There's pros and cons to either, but generally that's fine. What those approaches don't really do is help with the authenticity of a product, because it's with a UPC code, you can take them off, you can put them on a different box, you can change them quite easily. RFID tags are actually quite expensive. They're quite difficult to manage the installation of those. So really, we're kind of looking at different ways that we can tag a product or embed something in a product to actually prove its authenticity at the very beginning of the supply chain. And at Quantum Materials, we've come up with the idea of using something called quantum dots. What are quantum dots? Are there any chemists in the room? Because if there are, I'm sunk, because you'll probably know more than me. They've been around for a while. The term quantum dot was first coined in 1986, I think, by a Russian scientist and an American scientist working together. And what quantum dots are extremely small nanoscale particles, crystals. What are they made of? Base elements and simple compounds. Until relatively recently, various heavy metals were used, like cadmium. But that's not used so much anymore because it's very toxic, and there's regulations really being enacted right now to actually stop their use. So more friendly elements like silicon, carbon, compounds like zinc sulfide are quite commonly used right now. What quantum dots are, or the main characteristic of them, is that when they are excited by some energy source, like ultraviolet light, they themselves give off a light. They emit electrons, emit photons. And you might say, well, that's all very interesting, nice science experiment there. So what are they used for? Historically, and when I say historically, this is actually a pretty new commercialization effort. They're used in very expensive high-end displays. They're used in solar cells, in very powerful lighting, using batteries. They might in future be used in quantum computing memory. They could be used as sensors for things like for bioterror alerts. They've got a lot of potential uses. But how are they used in the world of anti-counterfeiting? Well, here's how. Quantum Materials has actually sort of patented a number of different processes for producing quantum dots. They've got about 50 patents, I believe. And the patents not only cover things like sort of how to produce the quantum dots quickly and cheaply, but also how to produce them so that they can be designed in a lab to be specific sizes between, say, 1,000 atoms, 100,000 atoms, and that determines the frequency and the optical signature of the energy they produce when they are excited. And what QMC can do is actually fine-tune the quantum dots that they produce, so they give off very specific optical signatures. And frankly, the different kinds of optical signatures is pretty limitless. I think it's in the billions. So using quantum dots, especially those produced by quantum materials, we can actually develop materials to embed in a product which provide a unique optical signature. They can be embedded in a product in a few different ways. The early examples of the POCs being run will be things like very specialist inks, thin film methods, but also actually embedding them in the physical manufacture is entirely possible, and that will come a little later. Not just solid products, but even in liquids. And yes, there have been some tests done putting quantum dots into oil, for instance, which there's quite a lot of in Texas. So using a combination of quantum dots, manufacturing them in very specific ways to give off optical signatures, embedding them into products provides that product with a physical optical signature. And what quantum materials have done is to combine that manufacturing process of quantum dots with blockchain technology. So at manufacture time, quantum dots can be produced. They can be essentially scanned and digitized. They can be then serialized onto a blockchain based system which holds their unique digital twin of the physical optical signature, and which can then be tracked and traced through a supply chain. So this is the kind of sort of device that might typically be used in that track and trace scenario. Even a device like a fairly new model smartphone or tablet can be used to actually scan for the existence of quantum dots and can actually determine the signature being produced and match that against the original stored on a blockchain. So the kind of POCs that I think we're looking at with running with quantum materials will probably begin in the general apparel market and then broaden out from there. We've got a couple in very different areas, and we're looking for more POCs. So what Quantum Materials has produced is something they call the QDX Platform, and part of that is a handheld device, an application running on a smartphone, and the rest of it is really a blockchain-based distributed ledger. The kind of technology that we are using in that ledger, QDX ledger, involves a few names you're going to be very familiar with. We are using the digital asset modeling language from Digital Asset. We're using that for a few reasons. One is because we think it's a great language to write our business logic in. We like the fact it really future-proofs us in terms of the blockchain platform that we use. It's very true in the world of supply chain. We know we're going to have to integrate with many other blockchains, whether that be an IBM Fabric or a version of Ethereum or a Corda. So we just know these blockchains are deployed out there in the field, and sooner than later, probably sooner, we're going to be asked to connect in with systems such as ERP systems and supply chain control towers and other track trace systems to actually bring our anti-counterfeit into other people's track trace architectures. So the use of DAML is very important to us. We decided ourselves to go with Hyperledger Sawtooth as our blockchain platform. Technical reasons there, just we like the openness, we like the scalability of the platform. But again, using DAML means that if we decide sometime down the road, if a new blockchain comes along that's better, we can switch to that with relative ease. We decided also that while we're providing a software as a service application, hosting it right now on Microsoft Azure, we really did not want to get involved in the entire deployment complexities, the management of that. And so we turned to a platform called Sextant from Blockchain Technology Partners. And they're the ones who essentially host the Hyperledger Sawtooth platform and host DAML smart contracts running on the Sawtooth platform on top of Azure. So we don't have to worry about sort of that side of things at all. We just get on and write our business logic. So we've got a great set of technology partners we're working with, and we ourselves are focusing on the business logic to build an anti-counterfeit solution. And with that, I think we're going to turn it over to Dan, who will talk a bit more about DAML and what its capabilities are. And then I think we'll take some joint Q&A and see if we can answer questions. Discussion.
There we go. You can hear me now? Cool. Thank you, Pete. So I'm by no means a supply chain expert whatsoever, but I always sort of struggle with the notion of blockchain, right? Blockchains are just data structures. It's garbage in, garbage out. And when you're dealing with something like a bearer asset or a dematerialized financial instrument that actually lives on the chain, I can completely understand how that would be governed by the rules of the chain and programmed in something like DAML. But with supply chain, I've always missed that link to the physical world. And as Pete was talking about those QR codes, it seemed too easy to be able to get around some of these approaches. So I think the Quantum Dots approach of actually embedding a physical piece in the product is really fascinating. So here to talk a bit about DAML, which is a relatively new smart contract language. We've been developing it at Digital Asset for about 4.5 years or so now. We open sourced it last April. And rather than just sort of pitch to you DAML as the technology, we also want to talk about more about the design decisions behind it, why we have done what we've done. It is very different from most smart contract alternatives out there, and look a bit about the futures or challenges within the blockchain space and how we are thinking about those and how we're designing DAML and technologies around it to address those as well. So what is DAML? It's a next generation smart contract language designed specifically for distributed multi-party applications or smart contracts. It is really built from the ground up for that purpose, working with major clients on mission critical replacement systems, which I'll touch on a little bit. We came across a lot of challenges trying to do that with conventional technologies or conventional technologies that are reapplied. So early on, we realized that just even for our own internal use, we needed to create a new language which was actually fit for purpose and designed for this case. So the high levels for the sort of properties here are, it's very concise. So as Pete was talking about, one of our goals really is you just focus on what actually matters to your business. You want to write the business logic of your application. You don't want to have to deal with the infrastructure. You don't want to have to manage how data is distributed or who gets to see what or which cryptographic hash functions you're using, where it's running. So DAML really, our goal with it is to abstract away, hide away as much of that complexity as possible so that you just write what is valuable to your business and to your customers, and DAML and the infrastructure below it automatically will take care of everything else. Fit for purpose. So I touched on this. It is actually designed for this. We've seen over the course of new technologies, when the web first came out, for example, people tried to repurpose Java, and they had Java applets, if anyone remembers that horrible experience of running Java applets on the web. Java was designed for desktop computing, so they needed to create a new language, and JavaScript was born to solve the specific problem of web-based applications. Now we're doing the same sort of thing. We're trying to use web-based technologies, desktop technologies, server-side technologies, and apply them to an application domain which is distributed in nature and fundamentally different from the way applications are architected previously. So DAML is really designed from the ground up with this problem domain in hand, and there are a lot of consequences of that decision. So portable, Pete touched on this a bit with the future-proofing. One of our goals is when we're talking to clients, though they want to prove the business value of their particular use case. They want to get a POC up and running that they can show internally, that they can actually test, is this even something we want to do? That's the first thing they want to do. It's not which technology should we choose. When you're building a new application, you don't start with which cloud provider should I pick before I even build my MVP and show it to people. You want to start on, just like with web technologies, I want a quick and dirty, high-level MVP. Then I will choose the correct technologies behind the scenes that meet the needs once I've proven that business value. So our clients sort of got a little, not stuck, but it was a challenge to actually get started with that, because you have to build a full-fledged network, or you have to actually have specialties in the particular underlying technologies. They weren't sure which one was the best one to choose. There's no standards or certification behind each of these technologies that they can actually trust and point to from a neutral vendor or a neutral organization. They don't know which one's going to win. Large technology companies are coming into the space. We've seen IBM early, Microsoft, VMware, many others, Amazon now. There may be a new system that comes out a year from now, 2 years from now, and you don't want to have to scrap everything that you've done and rebuild it for that specific platform. And lastly, interoperability. So big topic, a lot to unpack, means a lot of different things to different people. But as I'll talk about a little bit more, we're creating all these different networks. Currently, there's no tried and tested way to stitch them all together. And very much one of the design goals of DAML is to allow you to do atomic transactions across DAML apps, not just running on different networks, but running on different platform technology stacks across different networks. So who's using it today? So you heard from Pete about Quantum Materials Corp using it in supply chain. One of the largest projects that we've been working on for the last 4 years or so is with the Australian Securities Exchange, a top 10 exchange in the world, stock exchange by volume. They are not building a greenfield or testing or doing a POC on the side. They're decommissioning a 24-year-old core piece of their infrastructure and replacing it with a DAML-based application for clearing and settling all stocks in Australia. So regardless of which Australian stock you trade, ultimately that is going to be processed through DAML on a blockchain in the back end in production next year. So massive use case, real big first major production replacement project at scale that's actually going into production using DAML. The ISDA, the International Derivative Standards Organization, have a thing called the Common Domain Model. This is a common standards over how derivatives are processed throughout their life cycle that are used across the market by all the major financial institutions. They chose DAML to be the smart contract implementation to represent derivatives processing as part of the industry standard, CDM. We have projects with Change Healthcare in the healthcare space around claims adjudication, processing, Broadridge around US Treasury repo, which is a $1 trillion market, HKEX connecting Hong Kong stocks with mainland China stocks, and UBS and multiple other banks and healthcare companies as well. So, this is something that's been tried and tested. Got some serious projects underway. And we're looking forward to these major projects going to production over the next year and two. So where does it run? Right now, we have, we work with partners, and they integrate DAML into other platforms, and then they commercially support them for their customers. So Pete mentioned Hyperledger Sawtooth. We also have an integration with Hyperledger Fabric that we'll have more information on coming soon. Last week, we announced commercial support for Amazon QLDB, their cryptographic database with an immutable log, a centralized database, but with some additional cryptography to prove that you haven't tampered with it through blockchain technology partners. Amazon Aurora, traditional Postgres as a service database, R3's Corda. Digital Asset have a project called Project Danl, which I'm trying to come up with a new name for because I don't love. But this is a cloud service that really is I don't want to worry about any infrastructure. I don't even care which blockchain it's on. I just want it to work in like a platform as a service, serverless type environment, where you can just write your business logic in DAML, upload it, and it runs. And then a major partnership that we've been working on for a couple of years is with VMware around VMware blockchain, where DAML will be integrated into VMware blockchain and commercially supported by VMware, who are obviously a massive, massive infrastructure provider. And there's a question mark here because this morning, along with BTP, we announced the availability and commercial support through BTP of Hyperledger Besu. So this is the first Ethereum client that DAML has been integrated with. It means that we've got 3 of the main Hyperledger frameworks. So I was chair of the marketing committee at Hyperledger for about 3 years or so, and one of the biggest questions we got from people new to the space who didn't understand the technology was, how do I write a Hyperledger app? And there is no way to write a Hyperledger app. Hyperledger is an umbrella organization of multiple different technologies, and you have to choose your framework, and then you write your app for that framework. At least now, there's an option with DAML that you can write your app in DAML and then deploy it to each of these 3 frameworks. And as mentioned, so 4 of these platforms are commercially supported through our partner, blockchain technology partners, who are here today if you want to talk to them afterwards, through their product called Sextant for DAML that Quantum Materials Corp are using. So Sextant for DAML allows you to deploy your DAML applications on any of these 4 platforms, and it will take care of the deployment and management and the operations of actually running your application. So I highly recommend checking that out afterwards. So some of the challenges that we're facing as an industry and that we're trying to design for as a company. I'm not going to explain the value of blockchain here to you, replacing siloed databases with expensive messaging and APIs and reconciliation around that. But just this slide's really just to point out that we're in danger of recreating these kind of silos just at a slightly larger scale. So while we might be synchronizing across a few people in the supply chain network on one platform, a few people in trade finance on another, and other equities markets on another, the size of the silos will be bigger, but there's a chance they'll still be siloed across different technologies that can't talk to each other. And that is not the result that I got into this space to try and achieve. So we really need that true cross-chain interoperability, a way to actually enable all of these. I don't think everyone's going to go to a single network, right? Everyone could just agree to use the Ethereum mainnet, tomorrow. It's not going to happen for various reasons. And it's also single threading through one blockchain platform. There are going to be multiple networks. They are going to be predominantly permissioned, but those permission networks can be connected together, meshed together to create a larger permission network. And that is really the sort of driving vision of what we're trying to achieve. So a big property, write once, run anywhere. Right now, again, if you want to build a Sawtooth application, you have to download one of the Sawtooth SDKs, pick your favorite language, and build it for Sawtooth. You have to know a bit about how Sawtooth works, design your application with the actual platform infrastructure in mind. Same with Besu, build a Solidity app. It needs to be very bespoke to the Ethereum variants or flavors of clients that are out there. Fabric and chain code, similarly, you really actually have to have an understanding of what Fabric does, how you should interact with it. And your applications become actually sort of locked into the technology choice. There might be multiple vendors that support that technology choice, which is great, but you're still locked into that particular technology. If a better one comes along, if that one disappears, if your partner is using a different one and you need to use that for some reason, you essentially have to rewrite the vast majority of your application in a new bespoke language, a new bespoke platform. So with DAML, applications become common across platforms. You write the DAML app, you deploy it to Sawtooth, to Bezu, to Fabric, to Corda, to QLDB. If you want to change, you move it across. We recently had a very large client who'd been building out a serious use case, and they did decide to switch. And they moved their DAML application across. As a marketing guy, I'd love to say there were 0 tweaks. There was slight tweaks, but largely it was 90% unchanged, and that will go up. So already been done on a huge application with I think 100,000 lines of code or so. Minimal have to rewrites or edits to get that working on a completely different platform. So it really gives you the future-proofing, the application portability, that as a business, thinking about risk and thinking about what technology I choose today and what technology will be available in the market in the future, it's good to know that you've got optionality. And then lastly, the true cross-platform interoperability. So these different networks we're creating can't talk to each other. If you're using the same technology stacks as people in your network, then you might be able to talk together to each other. In some cases you can't. They're still, even if it's platform A and the other person's running platform A, they're not necessarily able to connect. You can do application level interoperability where you're coordinating things across 2 different networks, but you can't say necessarily do an atomic transaction where there's 2 pass or fail transactions on each network. That problem's obviously much worse when you're talking about different technology stacks. It becomes that much harder. What we are getting close to, and we'll be talking more about later this year, is DAML applications actually, regardless of the infrastructure, not only can they be ported across these different platforms, but they'll all be able to seamlessly connect and actually have true atomic transactions across all platforms. So that's what we've been working towards. DAML is open source, Apache 2. The SDK is free and available at daml.com. If you'd like to learn more about DAML or digital asset, you can email me at dan@daml or talk to me afterwards if there's not a huge rush. And learn more about Quantum Materials Corp at quantummaterialscorp.com. Pete, anything you want to add?
Nothing from me, I think. If you are interested in a proof of concept, my colleague John Harligan's the guy to talk to, because I'll just agree to everything, and John probably won't like that. But love to see if you've got any questions about what we're doing with DAML or what the roadmap for DAML is. Sure, we're here to answer them, or you can grab us afterwards.
The question about actually this is really spot on, because when I watched the video this morning, I followed the red thread video. I thought it was really good, but the first thing I thought of was just make that tag up anywhere along that whole supply chain, just move the tag, right? And I know that wasn't the point of the video.
Right.
But is something like Quantum Dots, you mentioned some of the material that could be applied to. Can it be applied to things like furniture, or are there any limitations to what it can apply to?
The short answer is it's pretty limitless. The long answer is it really does depend. You've really got to manufacture quantum dots on a sort of pretty much kind of case-by-case basis. There are kind of different recipes, if you like. So, and different quantum dots made from different things work better with embedding in some materials than others. So the short answer is pretty much it's possible, and the longer answer is it's an experiment, and especially right now that we're beginning. But what the company plans to essentially over the next sort of months, build up a catalog of recipes that are good for different kind of product scenarios. So furniture, I would say, is one that, yeah, it sounds like that shouldn't be a big issue. That's a very good question. And the answer, truthfully, is that it's still an experimental stage. There have been studies done that show that they are very significant, but again, it becomes down to a case of manufacturing them and putting them through that trial period. So that's probably not the answer you wanted, but it depends is the answer.
One?
Is there any technical reason why Ethereum or Quorum didn't show up on your list?
So Bezu is an Ethereum compatible client, so that is the first, our first Ethereum integration. And Quorum is entirely possible as well to do. Yeah.
Okay.
Cool. I think we're pretty much at time anyhow, so no more questions? Thank you.
Great, thank you. Come see us afterwards. Yeah.